Now we're going to take a look at solving some equations using our calculator. So our first equation, we have e to the x power equals 6. So in order to solve this one, we have to get the variable out of the exponent. So we're going to convert it to log form. You can think about this two ways. You can undo the curly law, or you can take that base e and take the natural log, which is also base e, of both sides. So I'm going to take the natural log of both sides. And when I do that, the natural log and the e cancel each other out, leaving us with x. So we have x equals the natural log of 6. So we're going to, that's solved exactly. You can also approximate it to the nearest thousandth anytime you round. For my class, give me 3 decimal places. So I got 1.792 when I rounded to the nearest thousandth. Next example, we've got natural log of x equals -2. So on this one, we're going to convert it to exponential form to get the variable as our answer instead of what we're taking the log of. So remember, natural log is base e, so e to the -2 power equals x. That's using our curly law. That would be solving it exactly, or you could have 1 over e squared if you want to get rid of that negative exponent. Rounding to the nearest thousandth, we get 0.135 on this one. We have 4 to the x power equals 72. So on this one, there's a couple of different ways to look at it. We can take log base 4 of both sides to cancel the base 4 in the x. So I can show you 2 different ways. That's one way. So make sure you take log base 4 of 72. And then, like I said, the log base 4 and the exponential base 4 cancel each other out, leaving you with x. But then we've got log base 4 of 72, which we can't type into the calculator. So we'll have to use change of base formula on this one to get our approximate answer. This would be our exact answer. If we wanted an approximate answer, remember change of base is log of 72 over log of 4. The base is always in the denominator. And I got for this one about 3.085. So there's method 1. If you like that method, feel free to skip seeing the next one. If you want another option for solving this one, go ahead and stick with me. So this one, instead of taking log base 4 of both sides, we can take either the common log or the natural log of both sides, because those are the bases that our calculator knows. Since I already did common log for this one, I'm going to go ahead and stick with that. So I'm going to take the common log of both sides. So log of 4 to the x power equals log of 72. And then we are going to use our power rule and bring that x out as a coefficient. So we get x times log of 4 equals log of 72. And then to finish solving for x, we're going to divide both sides by log of 4. So we got x equals log of 72 divided by log of 4. And this is kind of a little proof of the change of base formula and why it works. And then, of course, this is exactly what we got for our last answer. So we got 3.085 for this as well. And once again, I forgot to check my answers, so we're going to do that real quickly before we move on. Our first one, it was an exponential. Domain is all real numbers, so we're good. Our second one is a log. We got a positive answer. The domain of a log is x is greater than 0, so we got a positive answer, so that works for that one as well. And our last one is an exponential, so our answer works for that one as well, with the domain being all real numbers. All right, our next equation, slightly more complicated, but you guys know how to solve equations, so I am confident that you'll be able to follow me on this one. Your goal when you're solving exponential equations is to isolate the exponential and then use curly law or one of the other properties to finish solving. So the first thing I'm going to do is subtract 5 from both sides. Divide both sides by 2. And now we have that log isolated. So I'm going to use curly law to finish solving for x. Base of the natural log is e, so we have e to the negative 1/2 power equals x. That would be our exact answer. So if we're doing an approximate answer, we would have x is approximately equal to 0.607, rounding to the nearest thousandth. Next, again, trying to isolate that exponential, checking my answer. We've got a log. We got to make sure that the answer is positive, and it is. X is greater than 0, so that works for our domain. Next example, we're going to, again, start by isolating that exponential, subtracting 13 from both sides. And 41 minus 13 is 28. Next, we're going to divide both sides by 8, and this will isolate that exponential. So we have 28 divided by 8. You can leave it as 28/8. You could simplify it to 7/2, which is what I'm going to do. I'm going to leave this in as exact form as I can until I get to the end and punch everything in on my calculator. So here, now that we have our exponential isolated, is where we have those two options. Like I showed you on example C from the previous one. You can take the log of both sides, you can take the natural log of both sides, or you can take log base 4 of both sides. I like that second method, and this time I'm going to show you that it works with natural log as well. So I'm going to start by taking natural log of 4 to the 6 minus 2x power and the natural log of 7/2. Now I'm going to use the power rule of logs. I'm going to bring that exponent down as a coefficient. The whole exponent, 6 minus 2x, times natural log of 4 equals natural log of 7/2. So now I'm going to divide both sides by the natural log of 4, and that will isolate my 6 minus 2x. So because I'm now going to do a fraction within a fraction, I'm going to go ahead and convert that to a decimal just to make it a little bit less messy. And you can subtract 6 from both sides. At this point, you may want to go ahead and punch that into your calculator and get a decimal approximation, because from now on we're going to be subtracting 6 and then dividing by -2, and it will look really messy without a decimal approximation. So let's see if I've got one for you. Natural log of 3.5. Yep, I've got 0.904 is my decimal approximation. And then subtracting 6 from both sides. I'm going to keep the approximate sign because we have already rounded, so we do not have an exact answer anymore. And I got -5.096. And dividing it by -2, we get 2.548. Checking our answer, it's positive, so that looks good initially, and it's an exponential, domain is all real numbers, so we're good. And our final example, this time we have the log of a square root. I'm going to use curly law to begin with. 3 to the first power equals the square root of x plus 2. 3 to the first power, of course, is 3. And in order to start solving for x, I need to cancel that radical. So I'm going to square both sides. So now we get 9 equals x plus 2. And solving easily by subtracting 2 from both sides, we get x equals 7. It's positive, so that looks good for the log. Substituting it back in, we would get an answer that fits within our domain. And finally, some U-try problems. Again, please attempt these before you come to class. I would love to have a great discussion and answer any questions you have that you ran into as you attempted them. Thanks, and have a great night.